So many thanks for inviting me along here today. I hope you find my presentation both interesting and informative. I'm from the SEA. So who are the SEA? What is the SEA? People involved with REACH think SEA is socio-economic analysis. No, it's the Surface Engineering Association. We were founded in 1887, so we've been going for quite a number of years now. And we first started in the jewellery quarter in Birmingham. That's where electroplating was first commercially introduced, because a Birmingham doctor discovered that potassium cyanide was a very good electrolyte for gold and silver plating. So instead of producing very large items out of solid gold or solid silver, they could now produce it out of a much cheaper metal and then put the gold or silver coating on. The original company that first introduced electroplating was a company called Elkington's, and if you're ever in the jewellery quarter, you can still see their building there with one of the blue plaques outside. There's another logo you can see in the top corner there, SETS. What's that stand for? That's our European association. It's the European Committee for Surface Treatment. And that is an organisation that contains similar organisations to ourselves from each of the major member states throughout Europe. And currently I'm president of that organisation. And some of the things that we get involved in at a European level are looking at things called BREF documents, Best Available Techniques Reference Document. And currently we're working on one called STS, Surface Treatment Using Solvents. This is being coordinated by the European IPPC Bureau. Guess where they're based? In Seville. Very nice place to go. Just put a few pictures up there so you can see what cleaning is like today. But before I get into the main part of the presentation, I thought you might be interested in a couple of photos from the past, just to see how far we've come. How about that one? One of the first electroplating factories. It looks a bit like when I started work, actually, in the sector. Can you see the chap at the front here? He's actually got his bare hands in the tank. Some liquid in the tank. It looks like he's cleaning or washing the components. And what about the guys at the back there? Very similar. This chap here. No manual handling regulations there, Sarah. Yep. Look how he's bending over the tank there. That's where we came from. How about this one? This is actually from Germany, believe it or not, in the late 1950s. Okay? We've progressed, we've moved on. We've got a leather apron. We've got some gloves. He's probably wearing some Wellingtons as well to keep his feet dry. But that's about it. That looks very much like a hot alkali cleaner solution to remove oils and greases. And it's probably also removing the lining of the nasal passage as well. So this is where we've come from, but it's nothing like the way in which responsible companies are operating today. Here's an overview of what I'm going to talk about today, and we will have plenty of time for some questions at the end. And if anybody's got questions about other items to do with surface engineering, not just related to this presentation, quite happy to take those as well. Firstly, I'll give you some facts and figures regarding the surface engineering sector as a whole. Then have a look at why the cleaning cycle is so important. Then look at why we need to consider the total life cycle approach when looking at our cleaning options, and finally look at why we need sustainable solutions for the future. Quite often I'll get some of our members say to me, oh, I'd like to go down that route, but that piece of equipment, the capital cost on there, it's £80,000, it's £120,000. Yes, there might be upfront capital costs, but you need to look at the whole life cycle, and then you might get a different view. So, let's have a look at the size of the market. And what I've done here is I've looked at the different major manufacturing sectors that surface engineering has an impact on. The total surface engineering sector in the UK is worth around about £12.8 billion. That's total surface engineering. That includes engineering paints as well. For our colleagues from Germany, it's about £1 for €1 at the moment, so the figures are about the same. And in terms of European market, the largest market for surface engineering is Germany. Second is close run between Italy and France. Then we have the UK and then Spain. But if we have a look at this in a bit of detail, largest sector, this one at the bottom here, that's the construction sector. Accounts for around £3.6 billion, and almost 30% of the total surface engineering market is in the construction sector. That includes basically anything to do with construction, architectural coatings, but it also includes some of the speciality coatings on glass. You can put some very specialised coatings onto glass now, which mean the glass is self-cleaning. You don't have to clean the windows. You can get it so it reflects sunlight, or you can get a coating that stops the heat from escaping through the glass. That's all included in the construction sector. Next, number 2, automotive. Obviously a very big user of surface engineering. Just over 2.5 billion in the UK and growing all the time. Followed by the electronics sector, just over 2 billion there. We've seen that sector shrink quite a lot in the UK over recent years. A lot of the high volume production of electronics is now done in the Far East, not in the UK unfortunately. But a lot of this electronic sector here is very specialised, high value, multi-layer printed circuit boards. After the electronics, we've got the aerospace sector, which is, where's the aerospace hiding? Aerospace is in blue. So could just be there maybe, yeah, aerospace. And that includes both civil and military aircraft as well. So, very important sector. Now if we actually break that down by process, you can see that engineering paints is the biggest chunk of the market there. Just over 4.1 billion in paints. 32% of the market there. Electroplating, that's the second largest chunk there. About 3.6 billion. And then we have galvanising, third one over here. So those three processes together account for nearly 3/4 of the total market. But what's the most significant factor about this is, before you can carry out any of these surface engineering processes, you have to make sure that the surface has been cleaned properly. So you could say that this 12.8 billion pounds of coating, all of that depends on cleaning. And that depends on getting cleaning right. But just think of the value of all the finished products. Coatings is only a small percentage of the value of the finished product. So we're talking about some serious amounts of money here and a significant chunk of the UK GDP. Has anybody seen this? Fitz's Atlas? No? It's an atlas of coating defects. And it lists and gives photos of a whole host of coating defects. There's absolutely loads of them. Look, here's a few. I'm going to test. Can you read those from the back? I can't even read them from here. But there's a whole host there. There's adhesion failure, chalking, crazing. I've picked a few favourites. Fat edge. That's what my wife calls me sometimes. We've got fat edge, grinning, and rust jacking. And yes, those are all real defects. Does anybody actually know what fat edge is? Well, it's where you get a ridge of paint along the bottom edge of a surface. Grinning is where you have an inadequate coating or poor coverage and you can still see the base metal through. Rust jacking is where metal components rust and cause damage to stone or concrete structures that are surrounding them. What do a lot of these defects have in common? They're caused by poor or insufficient, incorrect cleaning. Does anybody know what that is? Yeah. It's a section of a printed circuit board showing a failure called mealing. There is such a word, mealing. It's a form of delamination of the conformal coating that occurs across the circuit board. Causes of mealing defects are almost always down to cleanliness. Poor cleanliness of the surface reduces good adhesion. If the surface is contaminated across a wide area, then mealing can occur due to the poor adhesion of the coating to the laminate. So you just imagine you've gone through all the process of producing that circuit board and then you get a failure like that at the end. Just imagine the costs that are involved in that. Something as small as a printed circuit board relies on you getting that cleaning right. Right, this is actually an aluminium stand. So I'm showing it sideways there, but it stands up upright. For a garden light. And there was a whole batch of these that were copper, nickel, chrome plated in China and then shipped out to Australia. And when they got to Australia, that was the condition they were in. And you can see here this complete lack of adhesion. This was caused by the electroplating company using a cleaning technique that was suitable for mild steel, but not suitable for aluminium, and therefore caused the lack of adhesion by not providing the necessary level of surface cleanliness. So the point I'm trying to get across here is you need to make sure that you understand the capabilities of your cleaning system to make sure that you don't get problems further down the line. Just imagine if that had been a component that had gone into a car and actually been assembled into a car and had got out on the production line. Just imagine the costs of the recall that would have been involved in that. Anybody seen this book? Or am I the only sad person that has a copy of this by my desk? It's an American publication, has the title Pollution Prevention and Control Technologies for Plating Operations. The original version of this was published in 1994, and in the foreword it said something that I thought was quite interesting. In this version, the later version, it says, surface engineering sector has come a long way since the first edition, 1994, but it's not entirely clear how much politicians have learnt in the meantime. I thought that was very good, because nothing's changed there then, has it? The book's produced by the National Centre for Manufacturing Sciences, and it looks at a whole host of issues, including moving to some of these supposedly more environmentally friendly cleaning options. And what I've done is I've put a couple of quotes here that are taken from the book, which did a lot of research and got in touch with a lot of companies in the US and said, can you tell us a little bit about your efforts to substitute some of these cleaning processes? At the top there, many substitutes contain cleating agents or surfactants that interfere with metal hydroxide precipitation. What does that mean? Essentially, some of the substances in the cleaning product had an impact on their effluent treatment plant and made the effluent treatment plant not work correctly. So you need to understand the full impact that your cleaning solution might have. No single answer for replacing solvent degreasing. Citric-based cleaners leave a residue. These are some first-hand examples of people that have been trying, and companies that have been trying to find alternatives. So substitution is not as easy as it seems. Surfing. Have any of you been to the surfing exhibition in the US? It's not that kind of surfing on the waves. It's surface finishing exhibition, largest exhibition in the States. It's held every year over a period of 3 days, and it features about 240 exhibitors and speakers, and has around about 80 presentations on a whole range of different topics, but they're all related to surface engineering. Here's a presentation that was given a few years ago. It's given by this guy here. Surface preparation of metals prior to plating. And I thought some of the comments that he made very, very relevant to today's discussion. The most important requirement in electroplating technology is cleanliness of the surface to which coatings are applied. This one. Cleaning operations have frequently been regarded as of minor importance. Lots of people say that. Oh, it's a necessary evil, we've got to clean the thing. But they don't see that as a key part of the operation. The successfully operated cleaning process requires careful audit and selection of proper chemistry, as well as proper equipment that facilitates and augments the effects of the chemistry. So you have to have the two hand in hand, the chemistry with the equipment. Here's another book. I like my books. Critical Cleaning, Applications, Process and Control. And I know Richard's read this, so I'm not the only one.
I said I own it, I never said I read it.
Oh, yeah. You had a copy of it. Okay. This is the second edition of the Handbook for Critical Cleaning, edited by Barbara and Edward Cannesberg. They're two leading experts in cleaning processes and the control of cleaning processes. Now, this book addresses some of today's manufacturing challenges, which includes increasing performance requirements, miniaturization, complex supply chains, economic pressures, and safety and environmental constraints. And it says here, cleaning is essential for proper performance, optimal quality, increased sales. Inadequate cleaning of product elements can lead to catastrophic failure of the entire system and serious hazards to individual general public and also the environment. Sorry to keep on pushing this point, but it's vital that you get it right. You have to get your cleaning system right. Otherwise, you will have issues further down the line. In a previous life, I've worked for a surface engineering company. I had a visit from a salesman. And then he said, "We know you're using trike. We've got a drop-in replacement for you." I said, "Well, how do you know that that's a drop-in replacement? You don't even know why we're using trike, and you don't even know what our cleaning requirements are. So how can you possibly have a drop-in replacement?" They didn't get the business. Here we've got two life cycle overviews that were produced by two Japanese guys. I will try and pronounce their names. Kikuchi and Hirao, I think it was. And this actually appeared in something called the Journal of Cleaner Production. There is such a thing, the Journal of Cleaner Production. So this top one is looking at the life cycle of a chlorinated organic solvent, and the bottom one, life cycle of an aqueous detergent. And the key point to this is that you need to look at the whole life cycle, not just the little cleaning bit. If you look at the aqueous cleaner, some people would just look at this little bit here. I've got my cleaning agent, I do the cleaning, and I've got some wastewater. They will then compare that to, I've got my solvent, I do some cleaning, I've got some waste, I have to distill, I have to do this, I have to do that and the other. This is much easier. But what about all this wastewater treatment? You might have sludge. You might need a discharge to consent. There's all sorts of other things that you need to consider. Aqueous cleaners might be absolutely ideal for what you want, but you need to have a look at the complete life cycle. Can be very difficult to do, can be very time consuming, but this is where you have to build up your trust in your suppliers and the suppliers of the equipment to help you with this. So what initially appeared to be the cheaper option could quite easily end up being far more expensive in the long run. One on sustainability here. This is a diagram that was presented at a conference in the Netherlands, the European Roundtable on Sustainable Production and Consumption. And what it's doing, it's looking at what's happened over the years with solvent cleaning. So if we go back a number of years, open top machines, company I worked for in the past, we used to manufacture exhaust systems for Triumph, motorcycle exhausts for Triumph. We had to polish them beforehand. So the guys would be there with these exhausts, they'd be polishing them. They'd then walk over to the open top degreaser, dip the exhaust in, take the exhaust out. Has it removed the polishing compo? Yes, I'll do a bit more polishing straight away. A bit more polishing compo, straight back into the open top degreaser. This is where we get these sort of figures from. This is looking at how much solvents needed to remove 100 kilograms of oil. So when you open top machine, that's how much solvent you have, 754 kilos. You'd lose that much in air emissions, 520, and this won't go to waste. So that's where we were all those years ago. We then started to get some regulatory pressures that were coming in, and we moved towards these closed machines. Straight away we had a massive reduction in the solvents usage, also significant reduction in air emissions. We still had some wastes there. But we then moved on and looked at the business models and changing of the business models so that we had the closed machines and chemical product services together. Solvent use now is down to just 15 kilos from 754. Air emissions 10, waste of 5 compared to there. And then finally, if we want to take that final step towards the chemical leasing, further reductions involved there. So it's very important, if you've got experience of using an open top degreaser and somebody comes along and says, why don't you go to a closed one, but it's going to cost you, I don't know, £200,000, £250,000, you think, wow, £250,000. But look how much solvent you're going to be saving. Look at the air emissions. Look at the waste. You have to look at the whole life cycle. I'm coming to the end now. That's quite quick, isn't it? Just trying to sum up. Every manufactured product requires some form of surface engineering for it to function correctly. And every surface engineering process relies on the correct level of cleaning for it to function correctly. So, cleaning plays a vital role in the UK manufacturing supply chain. Can't stress that enough. There are many options available, many options available, but you need to be careful with your selection. You need to be looking for a long-term, sustainable solution. And what you have to do is you do have to look at this total life cycle cost. Don't just look at that initial capital cost, because that will be the biggest mistake that you ever make. Total life cycle costs, and then I'm sure you will end up with the right solution. So, that's all, folks.